Welcome back, folks. Today we're working on a little winter project, given that it's January 27th, and although the ice is not completely frozen over the bay, it looks like we're going to have a very light ice winter, but it is time to work at projects. And this particular project, one of the items that we discovered was that the motor and the controller were heating up a little higher than what we were expecting, probably due to the fact that the motor was having to work extra hard because the prop was oversized and not matching the kilowatt capacity of the electric drive. In other words, it was too big, too much pitch on the prop for the size of motor that we're running. So this containment box contains the Kelly controller that came with this system. And for those of you who are not familiar, the controller is a vital link in the battery to power the motoring system. It takes the DC power of the batteries, converts it to an AC power, and then electronically controls both the RPM and direction forward and reverse of the turning shaft of the motor. So when these things get hot, they become less efficient, and we just felt that we could make some improvement with a little further adaptation. Doing a little reading and internet search, I found that Kelly controller produces a cooling plate which has an inflow and outflow, and then I proceeded after that, after removing and lining up the hoses, to go and drill out to access the ports for our cooling plate. I've decided to go with a single full-length 1/4-inch hose rather than use the right-angled elbow to come up the side and then another right angle to come out through the box. Just think that having the right angle is going to reduce the pressure of the flow. It would not work as effectively as a straight line hose, which just has a few soft curves in it and should function a little more efficiently. I think I will take it and run it under hot water, which softens up the hose, and I'll be able to extract that a little easier. I have put the hose under a little bit of hot water, soften it up, and now twist it onto our verbs coming out of the cooler. The other thing I might have done is put a little soap on it, but we pretty well have it there. And then I have a few crimps that came with the unit in order to secure the hose onto the barbs and prevent any leaking. There we have our stainless steel hose clamp. That goes on and goes over the barb in order to secure it. Then what we're going to do is we're going to place the cooling plate on the bottom of our containment box I'm going to secure it with a little butyl tape, which is very familiar to anybody who's operated in the marine environment. It's a putty looking element, but it is used for many purposes. In this particular sample, I have taken off my sailboat, and it was used as a sealant between the deck and the hull when they were put together over 40 years ago, and yet it's still pliable and it still has a good sealing adhesive capacity, but yet it's very malleable and workable, much like putty, but just does not harden up and will last for many, many years. And so our feed hoses will come through the box. This will likely be the outflow, and this will be the inflow. And those will hook up into our coolant system that we installed last summer, because our electric motor, had that capacity. So stand by for the next chapter.